Hey, my name is Christopher Shabbat, and I'm one of the supplemental instructors for Chem 1B this quarter, more specifically for Professor Zaera's class. Today he went over thermochemistry, and we're going to be doing an example relating to heat capacity. So today's problem says, what is the total energy required to change 9 grams of negative 36 degrees Celsius ice into 9 grams of 140 degrees Celsius steam? Now, it's important to note that whenever you're given one of these problems, you'll actually be given the constant that you need to get the answer. You'll always be given the enthalpy of fusion, the enthalpy of vaporization, the specific heat of solid H2O, as well as liquid H2O and gaseous H2O. So before we actually get into the calculation, I wanted to revisit the heating curve. He went over it in lecture, and he actually used it to guide him through the calculations. So we're going to be doing the same. This can actually be used as a map as we move through the problem to make sure that we're not missing any steps and to make sure that we're checking off all the boxes as we're moving through. I recommend to students that I have in my sessions that as soon as you get the exam, go to the back page of one of the sheets and then recreate the chart, because as you'll see, it'll be really helpful. So let's jump into the math. So step one for me, I like to start with where we're starting off and where we're trying to get to. So that would be negative 36 and 140. So just put a little mark on your map that you're trying to get to. You're moving from here. You're trying to get to maybe like right here. Now that we have those 2 points accounted for, let's just go over one big note. So if you're ever moving up a line, so up an upward sloping line to be more specific, you're going to use the equation Q equals Cmat. But if you're ever moving across a line, whoops, you're actually going to use Q equals delta Hg. So by up a line, across a line, we mean the freezing and melting points as well as the boiling and condensing points. Those are actually horizontal lines and require a different equation. Going from ice at negative 36 to 0, 0 to 100, and 100 to 140 require that we use Q equals Cmat. So if you're still confused, let's jump into the math. So once we start at negative 36, we have to move up here and then stop at the bridge first. So that means that we're going to go, step one is, the first question is which equation do we use? Now because we're moving up the line, we're going to use Q equals Cmat. So what's our C in this case? Well, because ice is solid, we're going to use the heat capacity of solid H2O, and that means we're using 2.087 joules per gram degree Celsius. Now, we want to cancel out our grams in degrees Celsius, so we need to use what? Our 9 grams. And then what's our change in temperature? Going from negative 36 to 0 means that our change in temperature is 36 degrees Celsius. These will both cancel. And if you plug that into your calculator, you should get 676.2 joules. Well, now we have to go to step 2, right? So now we need to move across this bridge. Now because the bridge is, we're crossing it, we're going to use Q equals delta Hg. We're not actually going to use Q equals Cmat. So what's our delta H? Well, we're going to use the enthalpy of fusion right here. So that would make it 333.6 joules per gram. And all we have to do is multiply by our grams to cancel out the grams and be left with joules. So we just multiply by 9 grams, cancel these out, and you should get 3002.4 joules. Now, we're just going to continue this until we get to our final destination. So 3, we want to move up this line to the next bridge. So that would make this, Q equals Cmat. Now our C in this case is no longer 2.087. We're actually working with water, which is liquid H2O. So that means we're working with 4.184 joules per gram degree Celsius. Again, multiplied by 9 grams. And our difference in temperature here is from 100 to 0. So that means it's 100 degrees Celsius. Cancel all this out. Plug that into your calculator, and you'll get 3,765.6 joules. Now, for step 4, we're back to crossing the bridge again. So because we're crossing the bridge, we're going to use our Q equals delta HG equation again. But in this case, our delta H is no longer 333.6. It's actually 2257. We're going to multiply that by our 9 grams. Our grams cancel, and we are left with 20,313 joules. Now, we're still not done. We still didn't get to our dot right here. So we need to do one more calculation, which I'll call step 5. And I'm going to move it over here. So for step 5, we're going up the line again. So we're going to use Q equals Cmat. And our C in this case is gaseous. So we're going to be using 2. So that means 2 joules per gram degree Celsius. Multiply that by 9 grams. And our change in temperature here is just 40 degrees, going from 100 degrees to 140. Degrees Celsius. That means these units cancel, and again, we're left with joules. In this case, if you plug it into your calculator, you should get 720 joules. So our final answer is actually just the summation of this right here, this box plus this box plus this box, this box, and this box. So our final answer, and if you plug this all into your calculator, you should get 28477.18 joules, or 28.5 kilojoules if you're looking for a prettier number. So this is pretty much as complex as these problems can get, making you move from one side of the map all the way to the other, and this one requires the most amount of steps. I wouldn't overthink these problems. This is as complicated as it can get. Just make sure your units always cancel and you're using the right constants. If you have any questions, feel free to come to SI office hours or comment down below, and we'll make sure to get those questions answered. Thank you.